Today we're building a feedback widget. In case you're unfamiliar, it's a way for you to capture user feedback from within your app. For example, here on Vercel, you can see that there's a feedback button in the navbar, and when you click it, you see that there's a dialog that pops up, and you can share your feedback, and you can also express how you feel using emojis, which is super fun. And another example is Notion. So Notion is a note-taking app, and if you go in the bottom right corner, you'll see that there's a question mark icon, and when you click it, you'll see that you have quick access to useful links like keyboard shortcuts, their changelog, and their documentation. But what's super nice is you can actually message Notion support from within Notion without actually needing to leave the app. So if you click message support, you'll see a widget that pops up and you can just ask questions, report bugs, which is super nice. Now, finally, my favorite example of a feedback widget is Linear. So Linear is an issue tracking tool / project management tool. And the way they do it is you have a help and support button in the bottom left corner. And when you click it, you see this dialog that pops up, and you can see a similar pattern here. You have quick links to documentation, settings, keyboard shortcuts, joining Slack. But what's super cool here is you can actually search Linear's documentation without leaving Linear. So you can be like Teams, and you can see documentation results for Teams, which is super cool. And if you want to submit feedback, there's a Contact Us button in the bottom right corner. And when you click it, a dialog pops up and they're asking you, okay, what is the issue? And, there's a place for you to write exactly what happened. And a super nice touch is you can actually attach images, files, or videos. This makes just, fixing users' issues a lot easier, which is super cool. Now, there are good reasons to add a feedback widget to your app. It's a lot less friction for your users since they don't need to leave your app to submit feedback, and you can include extra information about the user that's submitting the feedback, which can make your life a lot easier when you're trying to help them or understand their feedback. So an example is which page the user was on while they were submitting the feedback. Or maybe you can include information about this specific user, which can be very, very helpful. Now, my goal today is to teach you how to build a feedback widget using Next.js and hopefully inspire you to build your own. Now, this is a full stack project, so there will be a front-end component and a back-end component, and throughout this project, you'll be able to understand the different pieces and how they fit together, so it's perfect if you just started learning about Next.js. Now, without further ado, let's get started. Now, before actually building anything, let's go over how the feedback widget will work. So first, I'm going to make a few assumptions. Feedback widgets usually live behind authentication. This means you don't have to worry about anonymous feedback, and you will have access to the user's email since they will be logged in. Now, I won't be covering authentication today. However, if you want to add authentication to a Next.js app, I highly, highly recommend that you check out NextAuth. It's a super awesome library. Now, when it comes to my second assumption that I'm going to make is that I'm assuming you're going to use Next.js when you're building the actual app where the feedback widget will live. And the reason I'm saying this is the concepts and the code that I'll share today will be very, very similar if you have, let's say, a React app and an API. The only difference is where you're going to write your code. And I'll go into more detail about that later. Now, when it comes to the actual user experience that we'll build, here's what I had in mind. So this is a prototype. It's built using Figma, which is a design tool. And here we have a links for our navbar. And at the top, we have a feedback button. And when I click it, I see that a dialog pops up. We have a text area where users will type their feedback, and then they'll be able to submit it. Now, this is very minimal, and for a reason. I want us today to focus on building something that works. So something that gets the job done. We could have easily made this a lot more complex by, allowing users to express how they feel using emojis, allowing users to categorize this feedback. Is this general feedback? Is it a bug report? Is it an idea? We could have added many things. Maybe we could have allowed users to, attach files and videos and images. But yeah, I just want us to build something simple that gets the job done. Now, whenever the user submits the feedback, so they write their feedback and they click submit, we're going to have an endpoint that we'll build that will receive this data and then send an email to a dedicated email for handling support requests. So email is pretty simple. You can swap out this component eventually, as you will see with something like, I don't know, using Discord's API to send the feedback to a Discord channel, or Slack's API, same thing. Maybe you want to, send an SMS. To me, the most important thing is you'll be able to understand how to piece things together. And that's the goal of the project. Now, I already built a starter app where I kind of have like a starting point for this app. So let's take a look at what we have. So this is very similar to the prototype that we have. The only difference is it's more polished, but also when it comes to the feedback button, it's still in the same place, but when we click it, nothing happens. So let's take a look at the code that's powering this app right now. So this is a Next.js project, and in case you're new to Next.js, one of its many features is its file-based routing system. What this means is each file in the pages folder automatically becomes a route. So my app only has one route. It's the home route. It's this index file right here. But there's also this _app file. Now, this is the global app component. This is a component that wraps your entire Next.js app. And this place is perfect for importing global styles, adding a layout component that will persist across route changes, and that's exactly what I'm doing here. So if I actually navigate to this layout component by holding Command and then clicking, and I scroll down a little bit, you'll see that I have this feedback component. And if I open it, you'll see that the only thing I'm doing here is I'm returning a button that takes a few props. It takes a size prop. I'm setting the button to small. The button is outlined, and I'm also passing an icon. So this is the button that we see in the nav bar, to the right. And that's it, really. You'll also notice that all of the files have a .tsx file extension. And what this means is I'm just using TypeScript. Now, if you have no TypeScript experience, you have nothing to worry about. You'll be able to follow along just fine as long as you have JavaScript experience. And that's it for the starter code. It's pretty minimal, but it's a good start. And right now, the next step is for us to add a dialog that gets shown whenever someone clicks that feedback button. And to do that, we'll be leveraging Radix UI. When it comes to building dialogues using React, you should consider not building them yourself from scratch. Because while you can make them work, you might miss some accessibility details that will make the experience of interacting with this dialog for some of your users so much worse. Things related to focus management, being able to interact with the dialog using your keyboard, having the proper ARIA labels, and so much more. Now, thankfully, you don't have to worry about most of this stuff if you use Radix UI. Radix UI is a set of unstyled, accessible React components that you can just use. And we're going to use one of their components, which is the dialog component. It's fully accessible. And all we need to do is bring our own styles and just write our own CSS, which is pretty cool. So right now, this is the docs. I'm looking at it, and this is the example. And if we open it, we have a dialog. We can close it. And if you look at the code, you'll see that they're writing custom CSS. And it's using Stitches, which is a CSS and JS library. However, Radix works with any CSS solution of your choice. So yeah, I'm personally a fan of Tailwind. You can use whatever CSS library of your choice. However, you should definitely build accessible experiences, and Radix definitely helps with that. So to get started with Radix, all I need to do is install the component. So I'm going to do that right now. And let's do that. And what I'm going to do now is actually write the styles for this component. And don't worry, I'm not going to make you sit there, watch me write CSS. No one wants to see that, so be right back. So now when I click the feedback button, a dialog pops up and I can type my feedback in it. I can use the tab key to just cycle through the different dialog elements, which is awesome. The focus stays inside the dialog. I can dismiss the dialog by clicking the cross icon, or by clicking outside, or by hitting the escape key. which is awesome. Now let's actually take a look at how we built this. So now I'm inside the file where we have the feedback component, and the first thing we're doing is a namespace import, where dialog primitive here is a namespace object that contains all exports as properties. This is just a cleaner way for us to do imports rather than grab each individual component provided for us by Radix. We then use the useState hook from React to create a state variable that will keep track of the dialog state, whether it's open or closed. So useState returns an array where the first value is the state variable and the second value is the setter function. And we're passing these two values to the root component provided for us by Radix. And this is the component that contains all of the other dialogs components. So if we expand this, we'll notice that we have a trigger. This trigger is a button that will open the dialog. And you'll notice that we have this asChild prop here that we're setting to true. And the default behavior of Radix is that it will render a button for us as the trigger. And when we pass the asChild prop, what happens is we tell Radix, hey, don't render a button. We're going to take care of that by passing our own button. So this is just a way for us to prevent having duplicate nested buttons. So that's why this prop is very useful. Then we have an overlay. So the overlay is the background that sits behind the dialog. Usually it's a transparent dark gray color or a blurred background, depending on your design. And finally, we have the dialog's content, so the actual body of the dialog. And if we expand this, we'll notice that we have a title. This is the dialog's title, and it gets announced to screen readers, which is awesome. We then have a form, which contains a text area. And we have a button of type submit. And finally, we have a close component. So this close component renders a button, and this button will just close the dialog and dismiss it. And that's really it. The only thing that I wrote was styles, and that's just how easy it is to get started with Radix dialog, which is awesome. Now, when it comes to working with forms in React, I'm a big fan of a library called React Hook Form. So I'm using it here. So I'm just importing useForm from React Hook Form. And the useForm hook returns the following values. So we have a handle submit function. This function runs after a form is successfully submitted, so no validation errors. And we have a register function, which allows us to apply validation rules to any input element. And here I'm using it for the text area. And finally, we have a reset function that will reset the form and clear it. And we're also grabbing the errors object from the form state. And this will be populated with errors from the different inputs. And this is useful whenever we want to display an error to the user. Now, we also have an onSubmit handler. This is the function that will run when the form is successfully submitted. So if I scroll down a little bit, you'll see that in the form, I have an onSubmit prop that I'm passing to it the handle submit, and I'm calling the onSubmit function that's at the top. So far, we're not doing much in the onSubmit handler. All we're doing is we're resetting the form. So after a user types their feedback and it's successfully submitted, we just want to clear the form. And we're also passing false to set is open so that we actually dismiss the dialog after the user submits. So now the next step for us is to actually grab the submitted data that's coming from the form and send it to an API endpoint. Now, we can just write a plain old fetch to do that. However, it's a lot better to use a data fetching library, and that's where React Query comes in. React Query offers a set of powerful features that makes fetching, caching, and updating server state super easy. So first, we're going to set it up in our app, and then we're going to see how we're going to send the data from our front end to our API using React Query. To get started with React Query, first we'll install it. So I'm going to run npm install /react query. And in the root folder of my project, I'm going to create a new folder called lib. And in this folder, I'll create a new query client instance, and I'll just be able to reuse it across my entire project. So I'm going to create a new file and call it query client.ts. And in this file, I'm going to say export const query client equals new query client and import query client from React query. And then what we want to do is wrap our entire app in a query client provider and pass this query client instance to it. So I'm going to go to the _app file, and I'm going to say query client provider. And this takes a client prop, and I'm going to pass the query client instance that we just created. So that's it for the setup of React Query. Now let's take a look at how we can send the submitted data from our form to an API endpoint, which we'll create later. Now in React Query, whenever you want to handle creating, updating, or deleting data in your UI, you'll be using the useMutation hook. Now this is a React hook that takes as a parameter an asynchronous function, and this function returns a promise. So here we have const mutation equals useMutation, and this is our asynchronous function. And this asynchronous function takes as a parameter a new to do. And then all we're doing is we're sending an API request and passing this new to do. Now, this mutation object exposes useful fields that will allow us to explain to our users what exactly is happening throughout this mutation. So we have isLoading, which indicates whether or not this mutation is in progress. If it's true, we can display some sort of loading spinner. And we also have an isError field. This will be true if the mutation returns an error, will be false otherwise. And then we have isSuccess, which is the opposite of isError. And finally here we have mutate. Now this mutate function is the function that we'll use to actually trigger an API request to our API endpoint. And as you can see, it takes as a parameter an object that has an ID and a title, and this is our new to do, which is right at the top. So that's really it in terms of what you need to send an API request to an API endpoint. And I'm going to follow a similar pattern for the feedback widget app, and then we'll take a look at what that code looks like. So I just added a new mutation, and I called it feedback mutation. And as you can see here, I'm calling the useMutation hook, and I'm passing an asynchronous function. And this asynchronous function takes as an argument an object that has a message and an email. And then I'm just doing a fetch request to an API endpoint. It's going to be localhost 3000/API/feedback. Of course, this should be the URL of your app. And the method will be post. And then I'm just doing a JSON.stringify for the arguments, so the message. And for the email, I'm just hard coding a value of test@gmail.com because I don't have authentication. And then I'm just specifying the content type, saying that it's JSON. After that, what I'm doing is checking if the request was successful. If not, then we're throwing an error because React Query won't be able to tell whether or not the mutation was successful. It doesn't really care about that, so that's why we have to be explicit about it and throw an error. And if we don't have any errors, we're just going to return the JSON from the response. And after that, in the onSubmit handler, we're just calling feedback mutation.mutate, and we're passing the data object that comes from the form. So to test that everything works, if we go back to the app and we click on feedback, we can just say, I don't know, test. And if we open the network tab and we click send, we'll see that, okay, it's 404 because the API endpoint doesn't exist. But if we check the payload, we will see the message was test and the email was test@gmail.com. So this means our front end is functional and we're able to send data to our API. Now the next step is to actually build that API endpoint so that we can interact with it. Next.js makes it super easy to build an API. To create an endpoint, all you need to do is go to the pages folder, and inside it, you create a folder called API. Now, every single file that's inside the API folder will automatically become an API endpoint, which is super cool. So for us, we wanted to have an API endpoint that lives at the app's URL /API/feedback. So for us to achieve that, all we need to do is create a new file and call it feedback, and that's it. Now in this file, we're going to define a function. So let's do that. So let's say const handler equals async, and let's make this an error function. And in the end, we need to do a default export. So export default handler. Now this async function will take a request object and a response object. Now I'm using TypeScript, that's why there are red squiggly lines. Now Next.js ships with types that we can use for the API route. So we can just say next API response and next API request. Now the first step for us is we want to make sure that when someone sends a request to this endpoint, that the requests method is of type post. So we can just say if request.method is not equal to post, we can just return an error. So we can just say return res.status 400 and include a JSON message. Just say invalid request method. Now the next step for us is to grab the message and the email from the request body and apply validation on the server here to make sure that the data that we're working with is actually valid. So we can say const email and message equals request.body. And now I'm going to write some validation logic and we'll go over the code. So instead of writing a bunch of if statements to validate the incoming input, I'm using a schema validation library called Zod. Now the way Zod works is it allows you to describe the shape of your data using a schema, and you can compare the incoming input against this schema, and if you have any mismatches, you can throw an error. So that's what I'm doing here. First, I am importing z from Zod, and I'm defining a schema by calling z.object. And this object, our schema, is made up of two fields. We have a message and an email. The message is of type string, and it is required. So whenever someone is making an API call to our API, they must include a message. Then we're doing trim. So this is to remove all of the white spaces. And then we're checking the length of this feedback. And we want it to be at least 8 characters long. Otherwise, it's just way too short. It's going to be like hi or something. So having this trim and min function allow us to just have more useful feedback. Now, the second field we have is email. So email as well is a string and it's required. And if someone doesn't pass it, they will get this error, which is email is required. And finally, we're calling this email function, which validates this string and checks if it's a valid email or not. And if it's not, we will just say not a valid email. Now what we're doing is we define a variable called validation, and we're calling a safe parse function, and we're passing the request body. So what we're doing here is we're comparing our schema against the request body. However, if there are any mismatches between our schema and the request.body object, we won't throw an error. Instead, we will have a success field that we can check that if it's not true, so if it's set to false, then this means we have errors and we want to return a 400 status code, and we're going to include the errors in our response. And after that, all I'm doing is now I'm grabbing the email, since we checked that it's a valid email, from the request body and the message. And what we have left is for us to programmatically send an email. And to do that, I'll be using Postmark. Postmark is an email sending service that makes it easy to send all kinds of emails, whether that's marketing emails, password resets, newsletters, onboarding emails, you name it. Now, to get started, you're going to need an account. I already have one, so I'm just going to log in. And on Postmark, you have this concept of servers. And you can think of a server as a project. So it's a way for you to group the different types of emails that your app can either send or receive. So if, for example, you have multiple apps, and for all of them you want to use Postmark, you would create a separate server for each one of them. So now when I click on server, you'll see that I'm on a message streams tab. And for Postmark, it's just a way for you to group the different types of emails that your app can send or receive. So for the broadcast stream, this is the type of emails where you send an email to many users. For example, updating the terms of service. Another stream is the inbound stream, and this is when your app receives emails from your users. And finally, you have the transactional stream, and this is the type of stream where you send an email to a specific user. And that's the type of stream that we'll be using. Now, we'll be using Postmark's API to send the emails. And to do that, we're going to need an API key. So if we go to the API tokens tab, we can grab the API key, and I'm going to store it in an environment variable in my Next.js project. Now, it's time for us to actually get started with Postmark SDK and add it to our Next.js app. So now I'm in my Next.js project. I added my environment variable in a .env.local file. And now I'm going to start by installing Postmark's SDK. So to do that, I'll run npm install Postmark. Now, in the lib folder, I'm going to create a new instance of Postmark's SDK so I can use it across my entire project. So I'm going to create a new file, call it postmark.ts. And in this file, I'm going to say export const postmark equals new client. And I'm going to pass the API key. So I'm just going to say process.env.postmark_API key. Now I'm using TypeScript and it's complaining because this value can be undefined and it should be a string, but we can worry about that later. Now what I want to do is go to the API endpoint. So go to feedback.ts, and now we're going to use the SDK to send an email. So all we need to do is just say await postmark, and we'll import it, dot send email, and this takes an object. The first field is the from, so this should be from the user, so that's why we'll pass the email. And the subject, we can say new feedback. Now, the to field, we want it to be sent to a dedicated email for handling support requests. So I'm just going to type in my personal email since it's verified on Postmark. And finally, we want to add the message that the user actually sent to us. So we can say text body and then pass the message. And that's it. So now if I start my development server and I go to localhost 3000 and I create a new feedback, and let's say hello from feedback widget, and I click submit, and now I'm going to check my email, and I just got an email. Nice. So today we covered a lot of stuff, but there are still more things that you can explore that will make this project better. So the first thing is improving the user experience by adding animations. Here's a before and after comparison between the dialog we built and the same one, but with animations. You can see that the animated dialog just feels better. And we're also showing a toast after the submission, which provides information to the user about the result of them submitting a feedback. Now, the second thing we can explore is preventing someone from overwhelming our API by sending us a ton of requests. And we can do that by rate limiting the API endpoint. Now, both of these features, you'll find the final code for them on GitHub, and along with an explanation for how things work and how to set everything up. And that's it. Hopefully you found this talk useful. Would love to know what you think. Feel free to reach out if you have any questions. And yeah, thank you so much for watching.